Hi guys, welcome back. So in the last question we discussed till question number 46, which was write a Java program to find the second largest element in an array. Now we are going to start with question number 47, which is write a Java program to reverse an array. So what does this mean? That if I have an array of 1, 2, 3, 4, 5, basically I want it to become 5, 4, 3, 2, 1. Right, this is what I want to do. So what is basically happening is, first I had 1 2 3 4 5, then instead of 1 I want 5, that is the length minus 1, length minus 1, the value at the length minus 1 index. So this is what is happening, right? So how can I do this? Now earlier in the beginner level questions, or I think in the inter level only, we did a question of swapping, where we used a variable, a third variable, a temporary variable which stored the value of, let's say, another variable for a time when we had to swap a and b. So we created a temporary variable which stored the value of a for the time being, and then we shifted the value of b into a, and then b into is equal to temp. That's how we swap the variables, right? So this is quite similar to what we are going to do in this question to reverse the array. So let's start by creating an array first. Int array name, square brackets, int array is equal to, let's say, 1 2 3 4 5 only. Now our array is created. Now let's say start is equal to 0, and end is equal to array dot length minus 1. This is the indexing. We discussed it in detail in the previous question only. Why are we using array dot length minus 1? Why are we using 0 here? Because we needed to start from the 0th index, and this should start from the length minus 1 index, right? So now let's move on. So while start is less than end, okay, let's say we have a while loop, while start less than end. You can use for loop also if you want, but I'm using while loop. While start is less than end, as long as this is the condition, that because as soon as this becomes equal, we needed to stop, right? First this is 0, this is 4, we need to swap these. Then this is 1, this is 3, we need to swap these. Then this both becomes 2, the pointer from the start becomes 2, the pointer from the end becomes 2. So that's the same value, we need to stop here. So while start is less than end, the starting indexing is less than the ending indexing, what we need to do, we need to store, let's say, as we discussed the swapping method, we need to store the starting value temporarily in a variable, let's say temp only. So we are gonna store it here, okay. Then we are gonna store the value of the last one in the starting value, because right now the starting value has shifted to temp, so we can store the last value in the starting value. Our start is equal to, and then end. And then now we need to reverse the array, so we also need to store the value which was before this, which was the starting value, which is now stored in temp, right? So we need to store that value towards the end, and we need to keep doing this till the indexing becomes equal, till we have reached the middle. Is equal to temp, okay. Now once we have done this, we also need start to go from 0 and move forward, right? So we need start plus plus, and we need end minus minus, because we need end to go from array dot length minus 1 to, like, which is 4. This is basically, this thing is 4, so we need it to go from 4 to 3 to 2, right? So we needed to go -1. So end minus minus. This is now, we are going to end our loop here. So our loop has ended. After that, we are going to print the reversed array. Now we need to print the entire array, right? To print the entire array, we need to again use a loop because we need to print all the elements, right? So let's print reversed array, and then for each loop we discuss specifically for array. I hope you guys remember that. For int dot and then array name, we discussed it in detail in the loops video. You can go check it out if you are having any confusion in this. Then system dot out dot print dot out dot print and I, plus we need some space also, because if we don't put the space, it's gonna end up all cluttered. So let's run it. As you can see, the reversed array is 5 4 3 2 1. Though you don't necessarily have to put this space, but it won't look neat. See, 5 4 3 2 1. So it's up to you. So this was question number 47. Now let's move on to the next question. I'm commenting all the answers out for those of you who are seeing this later or just want to skip to the question and answers. You can go check out the REPL itself. Now question number 48, write a Java program to find the sum of elements in an array. So again, it's quite simple actually. Since we have done a lot of similar questions to this, so just instead of numbers from 1 to 10, instead of those, we have an array which has some values, right? So we need to add those numbers. So we are going to do it using loops only. First, let's declare an array. Int square brackets, then square brackets, then array is equal to 1 2 3 4 5. After that, int sum is equal to 0. It's very similar to the question we have done earlier regarding when we need to find the range. We had a given range from 0 to 10 and we need to find the sum of all the numbers, or we did it in the loop questions in beginner level only, I think. So you can check that out also if you are having any doubt in this. It's literally almost the same. It just instead of a range, we have an array here. So we are going to use for loop for int I is equal to 0, then I is less than the array length and I plus plus. What do we need to do? This time we need to add. Instead of just printing, we need to add also. So sum is equal to sum plus array bracket I, which is the value at index I. Okay, then outside the loop we are gonna print the sum. System dot out dot print ln sum of all elements in this array is sum. Okay, let's run the code now. As you can see, 15. So we have printed the sum. We can add as many values as we like. 45. So now this is how we did. It's very similar to the question where we printed a sum of all the numbers up to the value 10. We did it in this series only, so you can go check that out. This was one of the simplest questions in the inter level. Moving on to the next question. Next question says, write a Java program to find the GCD of two numbers. So what is GCD? GCD is the greatest common divisor of two numbers. greatest common factor that divides the two numbers, or HCF. You might have studied it in your class, I don't know, I think 5th or 6th class we used to study HCF, LCM. So that's exactly what this is. For example, the greatest common factor of 15 and 10 is 5. Alright, so it's clear what's GCD. Now how can we find it? Okay, to find the GCD, we basically need to find a number that divides both, right? Now what we can do is that first, let's say we have two numbers. Let's declare int a is equal to 56 and let's say b is equal to 98. Okay, so what we are going to do is as long as b is not equal to 0, okay, while b is not equal to 0, we are going to start a while loop where we are going to store the value of b in another variable. Why we are doing this, I'll explain in just a minute. Then b is equal to a remainder b. Then a will be equal to temp. Why we are doing this, I'll explain with an example so that you understand better. Okay, so what have we done? Let's use an easy example for now. Let's say a is equal to 5 and b is equal to 10. Okay, so now my temp becomes 10. Temp is equal to 10. Okay, so what is b? B is a remainder 10. So 5 divided by 10 and whatever the remainder is. Let's, instead of 5, let's make it 15. Okay, and temp is equal to 10 because b is 10. Then 15 divided by 10. What's the remainder? 5, right? So now my value of my b becomes 5. Okay, then a is equal to temp. That means a is equal to, a is equal to 10. But what is temp? Temp becomes b now, right? So the loop is gonna run again. Is b equal to 0? No. So the loop is gonna run again, right? So my temp now becomes b. What's b? B is 5. Then a is equal to temp. Yeah, just a second, guys. So now my temp becomes 5. B is equal to a divided by b. So what's a right now? A is 10. What's b right now? B is a percentage b only. So as you can see, b becomes 1. Now my a becomes 10. So a becomes 5. We'll do this again. So is my b equal to 0? No. So the code will run again. And so on till my b becomes equal to 0, and then we are going to get the final answer. So let's run this code now. We need to print also. As you can see, GCD is 14 for the two numbers. Let's So our program is working just fine. Alright, Now let's move on to the next question. Next question is very similar to this. We have to find the LCM of two numbers. So this is a homework question. It's very similar to the one we just did. Now write a Java program to check if a number is prime. So for the number to be prime, what's the condition? The number has to be divisible by 1 and the number itself. Right, a number that can only be divided by itself and 1. That's it. So for a number to be prime, now we have to write the code. So let's what we are going to do is we are going to run a loop from int I is equal to 2. As long as I is less than the number divided by 2, sorry, I is less than the number divided by 2, and then I plus plus. So if this number divided by I at any point becomes 0, then it won't be a prime. But if it's not becoming 0 at any point, it will be a prime. Okay, so let's write the code. Now first let's suppose a number that int number is equal to 29, then boolean is prime. Here I have created a boolean data type known as is prime whose value is true. Okay, then for int I is equal to 2, I is less than equal to the number divided by 2, and then I plus plus. Okay, as long as this condition is being satisfied, if the number modulus I at any point becomes 0, that means this condition, this is not prime, that is prime is false. Okay, that means is prime, we had set it as true, that the number is prime. But if it's not, that means is prime, this condition is not being satisfied. Then this condition is being satisfied, it's not divisible by the number itself and 1 only. So if this condition is being satisfied, is prime becomes false, because that means it's not a prime number. And as soon as it becomes false, we don't need it to continue checking, right? We need it to break there and then. Otherwise it will continue checking till the condition is being satisfied. We don't want that. We need to break it then and there, because even if it's divisible by any one number between 1 and the number itself, that means the condition now is like, that means it's not prime, it is composite. So we needed to break as soon as it happens only once. If we don't write break, it will keep going, so we don't want that. Now outside the loop, if the number is prime, okay, then we need to write number is a prime number. But if that becomes false, we are gonna print system.out.print that it is prime, else we are gonna print it's not prime. Oh god, else, and then we are gonna print it's not prime. Semicolon, semicolon. So now let's see if the loop is running. As you can see, it's a prime number. 97 is also a prime number. Then I'll write 100, let's say I write 100. 100 is not a prime number, so not prime. So the loop is the code is running. Now write a Java program. Next question. Write a Java program to check if a given year is a leap year. So how can we do that? Now to check if a given year is leap year, it should basically, so leap year is every 4 years, right? What's another condition for leap year? If the year divided by 100, or let's say first, if the year divided by 400, if that is equal to 0, then it's a leap year. But also the year divided by 100 should not be equal to 0. Why are we doing so? Because as you can see, that 1900 was not a leap year, but 2000 was a leap year. That means the number which is divisible by 100 only, like 1900, that is not a leap year. However, the number which is divisible by 400, that is a leap year, right? So I hope the concept is clear. So the number like 1900, when divided by 100, it should basically not be equal to 0, like 2024 when divided by 100 is not equal to 0, right? Or the number divided by 400 should be equal to 0. Also, of course, the year divided by 4 should be 0, because if that's not the case, then it's not a leap year. Okay, so we have 3 conditions to check. First, the primary condition, that it happens every 4 years. So year divided by 4, so year remainder 4 is equal to 0. Then the next condition, that either of these conditions should be satisfied, because as you can see, 1900 divided by 4, it is completely divisible, but as we just saw, it was not a leap year, right? So one of the conditions should be satisfied when it's a leap year, that it should either be divisible by 400 and that should be 0, or the year divisible by 100 should not be equal to 0. Okay, these 2 conditions should be satisfied. If these 3 conditions are, like if this condition and either of these conditions are being satisfied, it means our year is a leap year. Okay, otherwise it's not. Simple, right? So first let's take an example. For example, int year is equal to 1886. Now I have declared the year. Now let's say boolean is leap is false. Okay, now if what we just discussed, if year divided by 4, year remainder 4, not divided by 4, year remainder 4, year modulus 4 is equal to 0, then what do we need to do then? We need to check another condition, that if year divisible by 400, modulus 400 is equal to 0, then we are going to use logical OR. Year divisible by 100 is not equal to 0, so either of these conditions should also be true. Then the is leap becomes is leap year, that becomes true. Okay, so if now outside this we are going to print that if is leap year is true, right? is leap year, then we need to print that it is a leap year. Okay, otherwise it's not, right? Oh god. Yeah, else it's not a leap year. So let's run it now. 1886 was not a leap year. However, let's check 1800 first. 1800 was also not a leap year. Let's check 2024. It was a leap year. So hope this is clear. Moving on to the next question. The next question is, write a Java program to check if a given string starts with Java. So now if a given string is gonna start with Java, how can we check that, right? For example, or let's take the easy way out of this. We discussed string methods. There is a string method known as starts with. If we write start with, if I write bracket Java, it will check if the code starts with Java, if the string starts with Java. If it does, so basically we can simply use this method and get it printed. So how can we do this? First, let's create a string str is equal to Java is fun. Okay, semicolon. Next, we are gonna write if the input dot starts with, input, our string's name is str. If str dot starts with Java, then I needed to print yes, that it starts with Java. System.out.println, it starts with Java. Okay, else we are gonna print no, it does not start with Java. Okay, as you can see, it starts with Java. Now what if here instead of this I write small j? No, it does not start with Java. Java is case sensitive, so it's very important that if you are writing j here, then you have to write Java like this. Now again it will say that it starts with Java. Or if you want to take an input from the user and check all the conditions, you need to write if this starts with Java, or if like this, then or str dot starts with capital J and AVA, or the entire capital, all possible conditions, then it will run irrespective of the case. But Java is case sensitive, so we need to write accordingly. Okay, moving on to the next question. Write a Java program to check if a given string contains the substring code. Again, we have a string method. String methods are quite useful. You can explore all the string methods on W3 schools or Geeks for Geeks, wherever you like. So again, there is a string method known as contains. If we write str.contains, we can check if that string contains this particular word. So we are gonna it's pretty much this code only. I'll just copy it. Okay, so string str java code is fun. If string contains code, if it contains code, then we need to write it does, otherwise it does not. Okay, let's run it. As you can see, it does. If I remove this, it does not. No, it does not. So this question is also done. Very simple. String methods, you should explore string methods whenever you are free. You can search it on the net and explore it, because there are a lot of string methods. You cannot remember all the string methods, but you should read all the string methods at least once. Now, write a Java program to print numbers from 1 to 10 but break the loop when the number is even. This is very easy. Break and continue we discussed in the loop videos. It's a very easy concept. What does break does? If I write a condition, whatever condition, and then write break, so basically it's gonna stop the loop. So in this case, I want the condition that the number modulus 2 is equal to 0, then it should stop. So let's write the code for this. For then int I is equal to 1, I is less than equal to 10, I plus plus. If this is the condition for this, like the loop should run for this, and as soon as the number becomes divisible by 2, right, we need to stop it. So if modulus 2 is equal to 0, what do we need to do? Break. That's it. We need it to stop. And then outside the loop, I'm gonna print, oh, not outside the loop, I want all the values, so I'm gonna print inside the loop only. System.out.print I. Let's run it now. As you, what has happened here? Int I is equal to 1, I is less than equal to 10, and then I plus plus if I modulus 2. Yeah, we needed to break. So as soon as 2 divisible by 2 is 2 divided by 2 is equal to 0, remainder is equal to 0, right? So when we divide, if we remove this, let's see what will happen. Okay, as you can see, 1 2 3 4 5 6. Now as soon as it reaches to 2 divided by 2, remainder will give me 0. So it's gonna stop. This condition is being satisfied now, so it's gonna stop right there and then. So that's why we have gotten 1. Now the last question of interlevel. Write a Java program to print numbers from 1 to 10 but skip the number 7. Now in this case, we need to skip the number 7 and we want the loop to continue as it is. So with break, we also discussed about a continue statement. If we do the use continue in this only, if we use continue in this only, then what will happen? We'll get all the odd numbers 1 3 5, because it's gonna keep skipping the numbers which are satisfying this condition. As you can see, we are getting all the odd numbers. Now instead of this, we want that we needed to continue, we needed to skip the iteration when I is equal to 7, right? So we are just gonna write if I is equal to if I is equal to 7. The network is slow. As you can see, when it was equal to 0, nothing changed, but now that it is equal to 7, it has skipped 7. Okay, so it got printed like this only, so it has skipped 7. But if I is equal to 0 and then continue, then nothing will change. It will print all the numbers from 1 to 10, as you can see. So that's it for the inter level. Now we are finally done with the beginner and inter level. We'll move on to the advanced level questions in the next series. So get ready. See you next time. Bye bye.